Alright, so on this MacBook is an A1990 MacBook, so it's not producing any of the NAND supplies. So we have 0.9, we have 1.8 and 2.5. Right, so these are the three NAND supplies that is needed to turn on to power the NAND. So we have here, here's 2.5, we have 68, which is slowly discharging, and you can see it's discharging. 71, 72, 73, 74, we have 0.9, we have 321, and we have 1.8, which is 141. So as you can see, 2.5 volts is discharging. So if I plug in the power, right, let me plug in my USB-C tester. So I plug in the power, we flip it around, so we have 5 volts. See, boosting to 20 volts, right? And if I check the voltages now, I removed the Carina chip. As you can see, the Carina chip was hot, so the Carina has to produce 1.8 and 0.9 volts first before it can produce 2.5. This is the order, right? So I'm checking here, I'm not getting any voltage, no 1.8 volts. This is 0.9, sorry, this is 1.8, no 1.8, no 2.5, but I have 19 volts. So power delivery side on both sides is okay. The T2 chip is working because it's getting its power supply, working condition, power reset and PMU code reset, and 24 and 32.76 kilohertz from this PMU IC. And this is a 12 megahertz crystal. Once that working condition is okay, then it will communicate through this Carina chip, as you can see here, through the I2C line. So the I2C line is here. So we have I2C SDA and I2C SCL. Alright, so as you can see, it is directly talking to the T2 chip. Right, here it is. So as you can see, we have these two resistors here, I2C SDA, and this is the master U3900. Right, this is a system on a chip SoC, and it's going to the T2 chip, as you can see, which is U3900. Right, so once we have established a I2C line here, so if I use an oscilloscope, I can now check and see. Let me remove. Yeah. Alright, so I'm going to use the oscilloscope to check if the T2 chip is actually communicating with the Carina chip. As you can see here, we have Ocarina. So the name of this chip is Ocarina, right? The NAND BCC, or the NAND power supply. We have power OK. So this power OK from this chip for power OK 1, which is for a 2.5 volts power board. We have 0.9 volts, which is the main power OK. So this power OK is going to turn on PP 2.5, right? So this power OK, as you can see here, we have SSD 0 underscore power OK Carina, and this is going to turn on. Let me search. Right here, this power board. This power board, and we have another power board here, which is the sensing. Right, so we go here. As you can see, it is coming from PP bus. So this is 12 volts. Right, and this is, that's where I'm coming from. That's where I'm coming from. And as you can see here, this is also powering the Carina, which is 12 volts. PP bus. That's our alias. And this is coming to, this is a test point. So this is a power board from PB3V3, which is 12 volts. So PB3V3 underscore G3H, which is the 12 volts SNS, which is a sensing, right? And it gets that, and it gets the voltage enable, and we have voltage enable 2, and we have the I2C line, right? And we have a reset signal and the power OK signal. Then it will output 2.5, 0.9, 1.8, and that power board, which is this power OK, will turn on the secondary supply for the PP 2.5, which is coming to this power board, right? As you can see, it also helped to enable SSD 0 VR pp2.5 underscore SSD 0 VR pp2.5 underscore en underscore r. This is a lot of steps. See, as you can see, it's coming through the 0 ohm resistor here. Oh, sorry, this one. So it's going to turn on from here. Oh, here is it, sorry. So as you can see, I'm coming from the Ocarina chip. So the Ocarina chip has to produce its voltage first. Then once it produces 0.8, so 0.8, let me go over here. So 0.9, 0.8, 1.8 volts, it has to produce first. Then it will produce PP 2.5 volts from the power board from this side to turn on the enable signal for this, which is the TPS62180, which is a chip that is constantly burning the NANDs by sending this 12 volts over through the high current. Alright, so let's check if the I2C, let's check the I2C line. This signal is very important here. Where am I? Yeah. So we need to check here. If there's no I2C, if there's no SM bus communication here, then the chip cannot work, because this is passing all the information from the T2 chip to this chip, which is going to talk to the chip to tell it the amount of current is generated on the line, and the voltage, and for voltage adjustment, and for the output of the PWM circuit. Right, so this is a typical PWM circuit here. We have a coil. We have a coil here. We have a coil. We have output capacitors, and we have integrated MOSFETs, which is LX0, which is an integrated upper and lower MOSFET, and we have a PWM IC. Right, so as you can see, we have supplies. Right, these are the main 12 volts, which is coming in to turn on the upper MOSFET. See, buck 0, buck 1, VDD main. This is the main working voltage of the power supply of the chip, and these are connected to the two MOSFETs. Right, one for LX0 and one for LX1. So LX0 is here, and we have LX1 here, and we have buck. So all of these are upper and lower MOSFET, and the ground, which is this VSS ground. We have buck 0 ground, and we have buck 01 ground. Right, so this is for the lower MOSFET inside of the PWM IC here, and we have a native ground, which is analog ground, and this is a digital ground, as you can see here, which is connected for the power supply of the MOSFETs inside. The two switching MOSFETs, which is combined, and we can say it is a parallel to output 0.9 and 1.8 volts. Right, so we need that in order for it to work, but this is crucial, the I2C line here. So I'm going to just copy this signal, search. So we're going to look for this resistor here. As you can see, it's inside the T2 chip here. So I'm going to peel off this plastic here. This is at the edge of the board here. So I'm going to remove this plastic. Rough. Alright, so I'm going to remove this here. Let me go under the microscope because I can't see. So I can lift. Alright, so this is the T2 chip, and we had that's 1, 2, 3, 4, 5, 6, 7. So we're going to check here. See? SSD clock. And we have the data here. So we're going to check just one, which is the clock. So that's 1, 2, 3, 4, 5, 6, 7, 8. The 8th one. Alright, so let me get the oscilloscope ready. Right, everything is set. Alright, so we have 1, 2, 3, 4, 5, 6, 7, 8 there. So I'm going to connect the probe ground. I'm going to check here for communication. Alright, so I'm going to give power. Let's take a look at the oscilloscope. There we go. So as you can see, we have communication established, and this is clock. Alright, so as you can see, we have a clock there that center the signal, and we have a clock. So we know that the T2 is working. So as you can see, the T2 is working fine, so you know that everything is okay. So all I have to do now is just to replace this chip, and everything will be good. Alright. Ready? Yeah. Alright, so I have now wired the oscilloscope. As you can see, I have channel 1, channel 2. Channel 1, this is channel 2, as you can see, which is the red mark. And this is channel 2 with this on this side, right? So this is channel 1, right? So the red. So this is channel 1, and the red is channel 2, so blue and red, right? So I've now connected to 1.8 volts and 2.5 volts. So I give power now, as you can see. And we have 5 volts, and it's boosting slowly. Right, so after the boost, I will check. Right, so we have 19 volts there. So as you can see on the oscilloscope, channel 1, which is channel 1 is 1.8 volts. So this is 1 volts per division, so that's 2 volts. And channel 2, which is 500 millivolts. So this is half of it, so that's 0.8, 0.9. Right, so that's close to a volt. Let me go back to channel 1 selection. Alright, so that's 0.9 volts, 1.8 volts, sorry. Let me remove again. Let me clear the screen. Alright, so I'm going to set channel 2 to 2 volts per division. 1 volts per division, both of them. And my time base is set to 2 milliseconds. So I plug in the charger again. So let me check the voltages. So here I have 1.8, and I now have 2.5 volts. So as you can see now, channel 1, which is 1.8, so that's 1 volt, so that's 1, 2, and it's right above, below that grid there. So that's 1.8, and this is 2.5 volts, right? So half of the voltage there. So this is 200 millivolts, so that's 2.5 volts there, and this is 1.8 volts. So as you can see, 1.8 volts is outputted first, then after 2 milliseconds, then we have 2.5 volts. So as you see, the Carina chip have to produce 1.8 volts first, then after 2 milliseconds, then produce 2.5 volts. So as you can see, so the Carina chip have to communicate with the T2 chip first, and then it will output its 1.8 volts and 0.9, and then the power good from that Carina chip will turn on 2.5 volts. And that's the order.